Welcome to my channel. The present topic is Chemical Kinetics Class 12 Module 1. Please subscribe, like and share.
A chemical reaction involves reactants. Reactants will give products. Reactants will give products. That means a chemical reaction involves reactants and products. And of course, this reaction completes in a definite time. Then we can understand, as reaction completes in a definite time means how fast we can find how fast the reaction is. How fast the reaction is. That means whether the reaction completes in a quick time or it takes considerable time or very slow. Whether the reaction completes on its own or some energy is to be supplied. Some energy is to be supplied. That is, if we take say AgNO3 solution plus this is silver AgNO3 and sodium chloride. Whenever we mix the solutions of silver nitrate and sodium chloride, immediately we get a precipitate of AgCl. This is white precipitate plus NaNO3. So this reaction completes instantaneously. Instantaneously means within no time the reaction completes. On the other hand, if we consider another reaction, for example, nitrogen plus hydrogen gives NH3, ammonia. Nitrogen reacts with the hydrogen to form ammonia. And of course here certain conditions also we have to mention. And it takes considerable time. This reaction does not complete as the precipitation reaction. Considerable time. So in this chapter we can find out the time taken for a reaction and of course the reaction conditions for the completion of the reaction, and of course this chapter we call it as Chemical Kinetics. So Chemical Kinetics is a branch which deals with the reaction timings and the reaction conditions. Now, whenever we take the reaction, whenever we consider the reaction, we can find how fast the reaction completes or the reaction conditions, or otherwise sometimes we may find what is the quantum of the reaction completed in a given time. So the quantum of the reaction in a given time. Thermodynamic calculation, that is delta G. What is delta G? Delta G means it is free energy. Delta G is free energy. If delta G is less than 0, delta G is less than 0, the reaction is spontaneous. Spontaneous means the reaction goes on its own. If delta G is greater than 0, reaction is non-spontaneous. Non-spontaneous means we have to provide certain conditions to carry on the reaction. Delta G is equal to 0, the reaction is in equilibrium. Therefore, the thermodynamic data, that is delta G, gives whether the reaction is feasible or not. but it does not give, the thermodynamic calculations does not give the mechanism of the reaction, and it does not give the quantum of the reaction. That means how much quantity of reactants react to form product in a given time. So that quantum of the reaction that can be found by using chemical kinetics. Now let us discuss the chapter Chemical Kinetics. So this also addresses the questions like why some reactions are so faster. So this information should be known to experts, that is doctors and pharmacists. That is, if a medicine is administered to a person, the effect of medicine, the time taken by the medicine to affect the organs of the body or body parts, that should be known to a doctor or to a pharmacist. Then only they can prepare, they can manufacture the medicines. Similarly, blood clots. How much time does it take to clot the blood? So if the blood clotting goes on very quickly, whatever the wound causes, whatever the operations made, so they become success. If the blood does not clot quickly, the wound is not healed, or the wound made during the operations does not heal quickly. That's why the rate of the reaction or how fast the reaction goes on should be known to experts, that is doctors and pharmacists. Now let us discuss types of reactions. Types of reactions. Generally we can classify within a group reactions into three types. That is, number one, very fast reactions. Very fast reactions. For example, precipitation reactions. Precipitation reactions. Just now we discussed one reaction. Silver nitrate reacts with aqueous solutions of silver nitrate and sodium chloride. They react with each other and we get a white precipitate of silver chloride. That is very fast reaction. Similarly, all precipitation reactions. For example, lead nitrate, aqueous solution of lead nitrate and aqueous solution of potassium iodide. When these two aqueous solutions are mixed with one another, we get lead iodide, which is an yellow precipitate. And of course, we get potassium nitrate. So this reaction completes instantaneously or very fast. Within no time, the reaction completes. Such reactions are referred as very fast reactions. Similarly, reaction between sodium and water. If you keep a small piece of sodium in a water, in a beaker of water, this is a small piece of sodium, then what happens? Sodium reacts with water and of course we get Na plus H2O gives NaOH plus H2. Before starting the reaction, if you keep some, say phenolphthalein, an indicator, what happens? This solution becomes pink, right? So which is an indicator. Similarly, combustion reactions. For example, coal or wood or petrol, diesel, etc. When they combine, when they are ignited, they combine with oxygen and forms carbon dioxide. So reaction with petrol or diesel, the reaction is explosive, whereas reaction with coal and wood, the reactions are very fast, very slow reactions. Weathering of rocks. Weathering of rocks means rocks, when they react with atmospheric oxygen or water, so many changes takes place, and of course this is referred as weathering of rocks. And rusting of iron. rusting of iron. Iron, when it combines with oxygen in the presence of moisture, we get brown scales of Fe3, Fe2O3. Brown scales. So this is, you might have observed on everyday basis during the winter season. If you observe the railway tracks, early in the morning the railway tracks are observed with brown scales. And if you want to find the change between one day to other, the change is almost negligible. The change is almost not observed. That is, which is very, very slow reactions. There are certain reactions which are moderately slow, moderately fast or slow. Moderately slow reactions. Moderately slow reaction means the rate of the reaction or the speed of the reaction lies in between very fast reactions and very slow reactions. For example, manufacture of ammonia. So this is nitrogen plus hydrogen. Nitrogen and hydrogen combined and we get ammonia. So it takes considerable time, but it is not very slow like rusting of iron or weathering of rocks, etc. Whereas, and another reaction is inversion of cane sugar. Inversion of cane sugar. What is the formula of cane sugar? C12H22O11. When it combines with water, so hydrolysis takes place and we get C6H12O6, which we call it as glucose, and another same molecule C6H12O6, and this is fructose. So the process of decomposition of glucose into two molecules, cane sugar into two molecules, that is glucose and fructose, which we call it as inversion of cane sugar. So inversion of cane sugar, manufacture of ammonia, etc. They are considerably, they are moderate reactions, moderately slow reactions. So thus the reactions can be classified into three categories: very fast reactions, very slow reactions, and moderately slow reactions. Therefore, kinetics not only gives the speed of the reaction at which it goes on, but also describes the conditions. So, therefore, chemical kinetics gives the data about or information about the speed or rate of the reaction and reaction conditions. So both this information, both the data will be given by chemical kinetics. Now, how do we define the speed? So speed of a car, let us take in general speed of a car. How do we calculate the speed of the car? This is distance or displacement. Distance covered in a given time. Distance covered in a given time by time taken. Therefore, speed equal to distance by time. Now, if we apply this to a reaction, for for example, if you take a matchstick, if you ignite a matchstick, a flame is observed here. This is flame. So what happens? Ignite this and of course observe. What happens as the flame is going on? What happens? This stick burns and finally black substance is left or ash is left. Okay. Now, how long does it take? See, here we call it as reactant. That means the substance which burns is a reactant. What is the other reactant? Because burning takes place, the other reactant is nothing but oxygen. So, how much time does it take to burn half of the matchstick or completion of the matchstick? That is, If we take this as a quantity of the reactant, we can call it as concentration. Concentration means amount of the substance available. So quantity of reactant, rate of the reaction equal to quantity of reactant disappears. Quantity of the reactant disappears in a unit time, or it is equal to, because here product is formed, what happens as the reaction is going on, the product quantity increases. Therefore, the quantity of product appears in a given time. So the quantity of reactant disappears in a unit time, or the quantity of product appears in a given time is referred as rate of the reaction. So here quantity we can call it as concentration. Quantity is nothing but concentration. Quantity is nothing but concentration. Then what is the unit of concentration? Because we consider the speed of the reaction as distance covered by time taken. Distance is measured in meters, kilometers, etc. Time is measured in seconds, minutes, or hours. Right? In the same manner, quantity is nothing but concentration. Therefore, unit of concentration is given by mole per liter or decimeter cube or mole per decimeter cube. So this is the unit of concentration. Now let us consider a hypothetical reaction where R gives P. R means reactant, P means product. Now how do you find the rate of the reaction? The rate of the reaction is expressed in terms of quantity of the reactant disappears in unit time, R which is equal to the quantity of product appears in the given time. Concentration of any substance is expressed by keeping the symbol or formula in square brackets. Therefore, concentration of reactant is given by R. Concentration of product is given by P kept in square bracket. This is the concentration. And of course, the unit of this concentration is, already we discussed that the unit of concentration is nothing but mole per liter or mole per decimeter cube. So, now in this reaction, in this hypothetical reaction, R gives product. Initial concentration. Let the initial concentration of reactant be, say, R1, and time is T1. And after time T2, that means reaction is carried on and of course time is going on. We stop the reaction at time T2, and at time T2 concentration of R is given by R2, right? Now disappearance or decrease of reactant is given by R2 minus R1, that is final concentration minus initial concentration. Final concentration minus initial concentration. Final concentration is R2, initial concentration is R1. So this difference is denoted by delta R. Delta R equal to R2 minus R1. Remember this, final concentration of the reactant, as the reaction is going on, the reactant concentration goes on decreasing. Therefore, R2 is lesser than R1. Therefore, this is negative value. negative value. Therefore, disappearance of reactant is equal to minus delta R. Now, difference in time is T2 minus T1. Therefore, rate of the reaction is equal to rate of the reaction is given by minus delta R is equal to R2 minus R1 by T2 minus T1. So this is delta T. In the same manner, rate of the reaction in terms of product at time T1 equal T1, concentration of product that is kept in square bracket equal to P1, at time T2 this is P2. Keep this point in mind. As the reaction is going on, the concentration of the product increases. Therefore, the P2 is greater than P1. Therefore, delta P is equal to P2 minus P1. Since P2 is greater than P1, this is positive value. Okay, delta T equal to T2 minus T1. Now, rate equal to delta P by delta T is equal to P2 minus P1 by T2 minus T1. So, how do we conclude this? Rate? Rate equal to decrease in concentration of reactant by change in time is equal to increase in concentration of product by change in time. So this is given by minus delta R, decrease in concentration of reactant. Because there is decrease in concentration, it is denoted by the negative sign. Negative sign indicates decrease. So delta R by delta T is equal to change in concentration of the product. Because concentration increases, it is denoted by the plus. Plus indicates increase. So plus delta P by delta T. Speed of a car or speed of a vehicle cannot be constant. The reason, whenever a vehicle is on the road, the speed cannot be constant because of the traffic obstructions or speed breakers or any reason. So, speed can be found at a particular time or average speed. This is particular time, this is referred as instantaneous speed. Instantaneous speed. Instantaneous speed means speed at a particular time instance. Otherwise, it is average speed. Average speed means it is the total distance by total time. Total distance by total time. Right. Similarly, for a chemical reaction also, there are two types of speeds. For a chemical reaction, there is instantaneous speed. Instantaneous speed means disappearance of a reactant or appearance of a product at the given time instance. And average speed. So average speed equal to, how do we find average speed? Average speed equal to total decrease in concentration of reactant by time difference. This is minus delta R by delta T equal to R2 minus R1 by T2 minus T1. Instantaneous speed of a reaction can be calculated by calculating the slope of a graph of concentration of reactant versus time. So this is
Instantaneous rate and average rate. Instantaneous rate is that calculated at given point of time. Let the change in concentration of reactant in any given time or point of time be dr, and the change in time is dt. Instantaneous rate equal to change in concentration at any given point of time. Here change in concentration means it may be either concentration of reactant or concentration of product. So instantaneous rate is nothing but change in concentration at any given point of time by change in time. That is minus dr by dt, where minus dr is the change in concentration of any reactant in infinitesimally small time interval, whereas average rate equal to change in concentration in any time interval. So average rate equal to minus delta R by delta T, that is R2 minus R1 by T2 minus T1. Now let us see the graphs showing the rate with respect to reactant. So this is the graph showing the rate with respect to the reactant. Here initially the concentration of reactant is maximum. As time goes on, the concentration of reactant decreases, and of course finally it reaches a minimum value. Concentration of reactant is taken on y-axis and time is taken on x-axis. Now here rate average is found by taking change in concentration at time interval. Here R1 is the initial concentration and R2 is the final concentration at a time T2. So here at R1 the time is T1 and at R2 the time is T2. So minus delta R by delta T, that is rate average, is equal to R2 minus R1 by T2 minus T1. Now for finding the instantaneous rate, a tangent is drawn to the graph wherever we want to find the instantaneous rate. Suppose we want to find the instantaneous rate at this time interval. So here at this point a tangent is to be drawn. Now the slope of the tangent is nothing but y-intercept by x-intercept. So rate instantaneous equal to minus dr by dt, that is slope. So here rate instantaneous equal to minus dr by minus dt. Now let us see the graph showing the rate of reaction with respect to product. So this is the graph showing the rate of the reaction with respect to product. Here the product is at 0 concentration at time 0. So as time goes on, the concentration increases and it reaches to a maximum level. So the concentration of product is taken on y-axis and time is taken on x-axis. Now rate average equal to delta P. See here rate average equal to delta P by delta T equal to P2 minus P1 by T2 minus T1. Here please note that the concentration of product is positive value because the concentration goes on increasing. So this is rate average. Now here we want to find the instantaneous rate at this point of time. Therefore at this point of time a tangent is drawn and the slope of the tangent is nothing but y-intercept by x-intercept. So y-intercept is dp, x-intercept is dt. So rate instantaneous equal to dp by.
Now let us consider the reactions in gaseous state. So for a gaseous reaction at constant temperature, concentration is proportional to partial pressure. concentration is proportional to partial pressure. Therefore, what is the gas equation? Universal gas equation. PV equal to nRT, where the letters have usual notation: pressure, volume, number of moles, gas constant, and temperature. Rp equal to nRT by V. This implies P equal to CRT, where C is nothing but the concentration. N equal to W by M implies C equal to P by RT. Thus, P equal to W by P, W by V into RT by M, which is nothing but DRT by M, when G and T are given. When mole fraction is given, P equal, this is P total, partial pressure equal to P total into mole fraction of gas. Now the problem is, for the decomposition of dinitrogen pentoxide gas at 200 degrees centigrade, the reaction is N2O5 gas gives N2O4 plus half O2. This is the reaction. If the total pressure is 114 millimeter and after 25 minutes of the reaction, the total pressure of the gaseous mixture is found as 133 mm. Calculate the average rate of the reaction in atmosphere per minute and mole per liter per second. Now let us do this reaction. Now let us work out this problem. So here, initially only reactant is available. Only reactant available. Therefore, pressure of N2O5 is equal to 114 mm. Now, let the pressure N2O5 and O2 be X. Therefore, partial pressure of N2O5 equal to, total pressure is 133 minus, how much is given? This is X. So total pressure of N2O5 is 114 minus X. Now the reaction is N2O5 gas gives N2O4 plus 1 by 2 O2. Now this is pressure. Pressure of the substances 114 minus X gives X plus X, of course this is 1 by 2. Okay. Now total pressure equal to pressure of N2O5 plus pressure of N2O4 plus pressure of oxygen. Here total pressure is 133, pressure of N2O5 114 minus X, this is plus X, this is X by 2. So plus X minus X get cancelled. So 133 minus 114 equal to X by 2. Implies how much this is? X by 2 equal to 19. Implies X equal to 38 mm. Now we have to convert this millimeter pressure into atmospheres. So we know 1 atmospheric pressure equal to 760 mm. Therefore 38 mm equal to 38 by 760. So this is nothing but 19 one time, 2 times 19 4 times 2 by 40 equal to 1 by 20 equal to, this is equal to 0.5 into 10 to the power minus 1 atmosphere. Now average rate equal to how do we find average rate? Change in concentration by change in time. Change in concentration how much? 0.5 into 10 to the power minus 1 by change in time 25 minutes. So this is, how much this is? This is nothing but 0.2 into 10 to the power minus 3 atmospheric minute minus 1. Now let us find the rate in terms of moles per liter per minute. So the value of gas constant or the value of gas constant in terms of liter atmosphere is given as R equal to 0.0821 liter atmosphere K minus 1 mole minus 1. But we know that C equal to P by RT. So this is nothing but, what is P? 38 by 760 by gas constant. This is atmosphere. This is 0.0821 liter atmosphere K minus 1 mole minus 1 into temperature. Temperature is 200 degrees centigrade. If we convert this 200 degrees centigrade into Kelvin, this becomes 473 K. So K get cancelled, atmosphere get cancelled. So how much is this? So this is nothing but rate equal to change in concentration by time. This is the change in concentration. So 38 by 760 by 0.0821 liter mole minus 1 into 473 into 25 minutes. 25 minutes into 60 seconds. Okay. Now this can be written as, so this is equal to 1 by 38 by 760 1 by 20 into how many 4 decimal places are there? So 10,000 by 821 into 473 into 625 sir, 150. This is liter mole minus 1 second. So this is nothing but 2 zeros get cancelled here. So 1 by 20 into 100 by 821 into 473 into 50. This is nothing but 0 get cancelled here. 2, 5 2 times, 5 3 times. So this is 1 by 236 into 821 into 473 mole liter second. So if we calculate this, after simplification, this becomes 0.608581. 858 liter minus 1. This is mole minus 1. So this becomes mole second minus 1. So this can be written as 8.58 into 10 to the power minus 7 liter minus 1 mole second minus 1. So this is the problem.
We conclude this module here. Thank you.